Hi everyone, it's Abdulbaki from GACA. Today we are going to be looking at PLC, in full, Programmable Logic Controller. If you are new here, please do well to subscribe and turn on the notification bell so that you won't miss out on our videos. Now let's dive into the topic of today. PLC. A PLC, Programmable Logic Controller, is an industrial computer that makes sure that industrial processes work efficiently and effectively. It basically improves the productivity of the system. Okay? A Programmable Logic Controller is a device that controls your process by what? By getting data from the input module. Okay? It has something they call the input module. The function of the input module is to gather data from our input devices, your push buttons, your switches, your sensors. Okay? And then based on the written program inside that PLC, it controls your output devices, such as your motor, your valve, your actuators. All right? So the work of the PLC is basically to control, to automate your process, to make your process seamless with little human intervention. Okay? So the process by which the PLC collects signals, or let's say data, from your input devices and then check through the program that is written inside it and use that to do what? To control your output devices is what they call the PLC scan cycle. All right? Like I said, the process is what? Scan cycle. But the time in which the PLC used in doing that is called the what? The PLC scan time. All right? So basically, I said the PLC is a controller, it's a device that helps you control your industrial processes, and it does this by what? By collecting data from input devices, check through the program that is written on it, and then control your output devices. So basically, we have this system now. Okay? This particular system, I write a kind of motor control program on it. Okay? We're just basically to start and stop the motor. That's what the program is about. All right? So now, I think I've started the motor, but now let me try and put it off. Now, what happens is that by the time I press a button, you can see that my output is on. Okay? One of the outputs is on. What happens is that I have pressed the start button to start the what? To start the motor. What the PLC does in that regard is that by the time I'm pressing that input, the input sends signal to the PLC. The PLC now check through the program that is written on it to see what does it mean to have this signal. Okay? Now, if I have this signal, what am I supposed to do? By the time it checks the program, it realizes that yes, I'm supposed to put on this indicator. For example, in this particular PLC, what I have tried to do is to program a kind of motor control in it. Majorly, it is just to start and stop the motor. One indicator is for the motor itself. Another indicator is to show that the motor is on. This indicator is to show that the motor is what? Is off. Why this indicator is to show that the motor has been off for longer than it should. Okay? That's what this application is about. So if I press this start button now, you can see that the motor is on and the indicator light for the motor is what? Is on. The PLC went to the program to see. By the time there is signal from this start button, what should I do? Okay, I should on the motor. And if the motor is on, the indicator light should also be on to show that the motor is on. Okay? If I press this stop button now, you can see that the indicator light to show that the motor is off is also what? On. Now, after some time, this one joins it to show that it is on for long. Don't mind the seconds, the few seconds that is between them. It's just to show us some application here. In real life, it may be longer than that. All right? So basically, you can see that although when I wanted to start my motor, I press this button, okay? And then when I wanted to stop my motor, I press what? This button too, okay? But I didn't have to press any other button for this other indicator to come on, okay? What we have done there is that we have used a timer. So timing application come into play there. So there are a lot of things you can do with your PLC. You can use comparators when you have to compare between variables. You can use counter when you have to count something along your line of production. All right. So PLC is just there to make your life easy, to make your industrial processes operate seamlessly. That is what the PLC is for. Now, the PLC are used in various industries. You see them being used in agriculture, you see them being used in food and beverages, you see them being used in pharmaceuticals, you see them being used in oil and gas. They are very useful in those places. And what makes them stand out from other controller options that you have? One of the major reasons why they stand out is their ruggedness. They can withstand rugged environments. They can withstand high heat. Okay? They can withstand high heat. Also, they also have some level of dust they can accommodate that some other controllers cannot. Okay? If you put some other controller, especially the embedded systems that they use, the Raspberry Pi, the Arduino, if you put them in industrial settings, they may melt away, while the PLC still stand stronger. Okay, so they are also easy to troubleshoot. Okay, they are easy to troubleshoot. There are some features that come with their software that makes it easy to troubleshoot. So PLC have some features that make them stand out from all other controllers. Now, I was saying something earlier that the PLC does what? Check through the input, and then based on the pre-rating program inside it, it controls the output. Now, I want to emphasize on the program now. The program that is written inside the PLC is made possible by a programming language. Okay? So the programming language that are used for programming PLC are standardized by the International Electrotechnical Commission, IEC 61131. Okay? So those programming languages are the ladder diagram, the function block diagram, the statement list or instruction list, the structured text, and the sequential function chart. Okay? The most commonly used is the ladder diagram because it kind of mimics the electromechanical relay circuits that were used that were used in controlling automation processes before. Okay. Now, other programming languages are also used in programming the PLC. All of them have their own edge over each other, but the simplicity of the ladder diagram is what makes it more common and more friendly to some people to use. Okay. Now, of recent, the conventional programming languages such as C and Python too are being adopted in programming PLCs. And I will not be surprised in years to come when they become the major, if they become the major programming languages that are being used to program the PLC, the C and the Python. For today, that will be the end of we trying to tell ourselves about programmable logic controller. If you are interested in knowing more about PLCs, you can go to our website, greenpegacademy.com, to see the list of courses that we have there. We have a variety of courses for you to take you to from beginner to expert in PLC programming. Okay, we have courses on Siemens, we have courses on Allen Bradley PLC, and some other PLC like PLC Next, Delta, and some other ones. So if you are interested in building a career in PLC programming, go to greenpegacademy.com and sign up for a program that interests you. Meanwhile, don't forget to subscribe and turn on the notification bell so that you will not miss out on our next set of videos. This year, we have a lot in stock for you. Thank you. See you soon.